The 6.3 quick check has to do with the heating curve and combining the two different kinds of changes that might occur for a substance. So we're starting off here. Okay, notice that there is some information given at the top, and this information will be given to you during an exam, so you don't have to memorize this. Okay, but it says consider this heating curve, fill in the states for each segments. So this you need to kind of get sorted out in your brain. So this A to B segment, that's a solid. Okay, the C to D, that's going to be liquid. And the E to F, that's going to be gas, solid, liquid, and gas. Okay, in between, this is going to be solid changing to liquid, and this is going to be liquid changing to gas. So solid, liquid, gas, solid, liquid, liquid, gas. Darken the segments in which the equation Q equals m delta T C sub P applies. Okay, so what we're talking about is in this part right here, and this part here, and this part here, okay, all three of those, that's where we would use this equation Q equals m delta T C sub P. On the flat parts, we would use the simpler equation Q equals m times delta H. The dark segments represent change in what? Temperature, state, both temperature and state. Okay, those two do not ever change together. Okay, either you're going to get a change in temperature or a change in state. And for these parts here, because the clue is it's got a delta T, which is change in temperature. So that's the answer, is change in temperature for those slanty parts. The other parts, you have a change in state. Okay, now it says a 25-gram chunk of ice, negative 30, is heated until it's liquid at 85 degrees. So indicate on this heating curve the starting and ending point. So think about this. If I have a chunk of ice at negative 30, okay, well right here, that is a chunk of ice at 0, okay, and this is at 100. So we're not there, we're actually before that. So we're here at negative 30, so we're going to go this much. And then heat it until it's liquid at 85. Well, that means we're going to melt it, and then we're going to go up to 85, almost this way here. So there are three segments on our heating curve. That means we're going to have three little problems when we calculate. The two slanty parts here, okay, those are going to be Q equals m delta T C sub P. And this other part, that part, is going to be Q equals m delta H. And because we're talking about solid and liquid, that's the delta H of fusion. So let's just calculate things up. So calculate the energy absorbed by the ice as it changes to liquid at 85 degrees. So the first segment down here, A to B, that's going to be Q equals m delta T Cp. And the mass is 25 grams. And that's going to be the same for all three segments. Okay, the change in temperature, we're going from negative 30 to 0, so it's 0 minus negative 30, so it's 30 degrees. And the Cp for ice, we'd have to look back at the top, the Cp for ice, 2.10 joules per gram degree. So when I calculate that up, I get 1,575 joules. Okay, so that is the energy for this first little segment. Okay, second segment, I'm going to color code it green. Then I have Q equals m delta H of fusion. Okay, so that's going to be 25 grams again. But this time I have the delta H of fusion, so look back again, delta H of fusion, that's my 333 joules for every gram. So all I have to do is calculate, and I'm just going to say it's 25 times 333, and I get 8,325 joules. Okay, then let's do it yellow here for this last part. Okay, so this is going to be Q equals m delta T Cp. And so I'm going to have 25 grams. Okay, this time my temperature changes, it ends at 85. I started at 0, so it's 85 degrees. So 25 times 85. And I need my CP for water, and I'm not going to look it up because I've used this enough. So 4.18 joules per gram degree. And so this time, so it's 25 times 85 times 4.18. And I get 8,882.5 joules. So I have three different values here. This is for my first segment. This is for my second. So this is when it warms up the ice. This is when it melts the ice. And this is when it warms up the liquid. And so my answer is to add those three together. And when I add those three together, I get a total of 18,782.5 joules. So the question is, calculate the energy absorbed by the ice as it melts to liquid at 85 degrees. I do three separate problems, and my final answer, 18,000. And that's this kind of problem.